So today we're going to do a little extra help on demand, and what we're going to talk about is vertical and horizontal shift to different types of functions. So let me do that right now. Going to make these examples up off the top of my head. First off, a general typical equation for a quadratic one would be this. Y equals a times x minus h squared plus k. And let me give you several examples of those and show you how they turn out. So for example, I might have y equals, and let's ignore the a, let's not even put a value there, x minus 4 squared plus 3. Then we'll do a second one. Again, we'll ignore the a. Y equals x plus 3 squared plus 1. And then we'll do a third one that will say y equals, and now for the first time I'm going to include an a of negative 1. Let's go x plus 2 squared minus 4. And then we'll go with another one yet that looks like this. Y equals 2 times x minus 4 squared plus 3. Notice it's just like the first one, except I'm going to put a 2 in front of it. And then this last one that we'll go over is y equals 1/2 x plus 3 squared plus 1. Notice these pair up, but it's a half, and I'm also going to put a negative in front of that one. And what I would like you guys to do is use your calculators to follow along. Now, I would prefer you be able to do these without your calculators, because that teaches you the skill. But the calculator is there as a nice backup, and it will graph these much quicker than you will be able to do if you plotted points. So the first one says y equals x minus 4 squared plus 3. Notice that the h and the k pair up. In this case, the h pairs up with the 4, and the k pairs up with the 3. H is what we call horizontal shift, and k is what we call vertical shift. I'm going to write vertical with a k, even though I know it is with a c, just to make an emphasis that it's vertical shift. And the thing you have to remember about horizontal shift is it's always reversed in the parentheses. Remember how if we solved a quadratic equation like this, x squared plus 3x plus 2 is 0, and we factored it, and we got x plus 2 times x plus 1 is 0, then maybe it's the guy on the left, maybe it's the guy on the right, and I come up with negative 2 and negative 1. Well, do you see how the actual roots are reversed from what it says in the parentheses? Well, that's the same thing here. We want reversal what it says in the parentheses. So what this means is, as I look at this, I might say, oh, I go 4 to the left because of the negative. No, I reverse it. I go 4 to the right. So 1, 2, 3, 4. And then vertical shift is always what it is, up 3. 1, 2, 3. So here's my vertex, and here's how my parabola would look. Okay? Now I'll go to the blue one, which says almost the same thing, except it's positive 3 in here, which means it's really x minus negative 3. So I'm going to go 3 to the left, 1, 2, 3, up 1. And there would be my parabola. Then I would go to the green one, which is, you tell me now for a second. I'm going to go horizontal shift here, 2 units in which direction? I hope you said in the negative direction, because this is really x minus negative 2. So I'm going to go 2 in the right to the right, and then down 4. 1, 2, 3, 4. And here's the big difference. Now I have a negative in front, and the negative flips it, puts the parabola facing down like a frown. And if you were to graph any of these 3 on your graphing calculator, they would all look exactly like what we drew. So let's do a little bit of work here with this one, the y equals 2 times x minus 4 squared. It is going to look, notice something here. X minus 4 squared plus 3 is the same. The only difference is this 2 in front. What's the role of the function of the 2? Well, the role of the function of the 2 does not affect the vertex. We're still going to go 4 units to the right and up 3, but it's going to be more narrow. Notice the difference. More narrow than its partner. Its partner is the normal standard width. Because this is a 2 in front, it means things are getting twice as tall, twice as fast, which makes it more narrow. And then, if I take a look at these guys here, again, the x plus 3 squared plus 1 is the same, but it's negative 1/2 in the front. Negative means flip it, just like it did here on the green one, and half means half as wide. So I'm going to take the same vertex, negative 3, 1, and then I'm going to open downwards and wider. Wider because of the 1/2. Okay, so that's the basic idea behind vertical and horizontal shift. Horizontal in the parentheses, vertical at the end. The role of the A is to make it either more narrow or more wide, and if it's negative, it flips it. Now, these ideas are not limited to parabolas. For instance, I can do y equals x plus 7 absolute. Or I could do y equals 2 absolute x minus 1 plus 4. Or I could do y equals 2 to the x plus 3. And knowing my parent function graphs, in this case, my parent function is an absolute value, v. We did parabolas before. As soon as I see something squared, the parabola is the parent function for that. The parent function again for the middle one, because its absolute value will be a v again. And the parent function for this guy will be the exponential graph, which looks like that. We've done a little exponential. We'll do a lot more about that in the coming days. So, I'm in the packaging symbol, in the grouping symbols. That's the same as a parenthesis. I'm going to move 7 to the left. 1, 2, 3, 4, 5, 6, 7. And there is my absolute value graph. Again, please check this on the calculator, see how it works. Ultimately, we don't want you to have to use the calculator. We want you to be able, by inspection, to look at it and say, okay, that guy goes 7 to the left. Next one, I have both vertical and horizontal shift. Here's my vertical shift. Remember, vertical always comes at the end. Here is my horizontal, which always comes in the grouping symbol. But I also have a 2 to make it more narrow. So I'm going to go 1 to the right. I'm going to go 4 up. And then I'm going to make it more narrow than a normal absolute value graph. Because of the 2 in front, it makes things twice as big. And then for y equals 2 to the x plus 3, we haven't done a lot with this, so I'm just going to very lightly draw what the typical y equals 2 to the x graph would look like. That would be it. So now, the correct value here, I'm going to go up 3. So from here, I'm going to go 1, 2, 3. And there's my graph. Okay? All right, so that's an idea of vertical, horizontal shift. When you flip it, when you don't, for example, if I had put a negative in front of this, it would just make the graph go down like that. Okay? So there's horizontal, vertical shift, the effect of the A in the front, the effect in the grouping symbol, and the effect of the vertical on the end. Okay? All right. I hope that extra help helped you a little bit, should you need it. Have a great day. Bye-bye.